In the previous video, we have seen the arithmetic logic unit, A register, B register, program counter, data pointer, and clock circuitry. In this video, we see the RAM, division, and program status word and ports. So RAM 8051 microcontroller comes with certain amount of RAM. So this 8051, the one we are considering is having, it comes with 128 bytes of RAM. 128 bytes of RAM. So this 128 bytes of RAM are divided into three different groups. The first group is the register bank group, register bank. The second one is this is what is the first group, register bank group. Four register banks like bank 0, bank 1, bank 2, and bank 3. The next division is the bit addressable bytes. 16-bit addressable bytes. So this area is bit addressable area. Now the next division is going to be 80 bytes, which are general purpose RAM locations or scratch pad memory. So once again, so this entire 128 bytes, this 128 bytes of memory is divided into three parts. So the first part is 32 bytes, 32 bytes of 32 bytes, which are called as register bank bytes. Bank 0, bank 1, bank 2, and bank 3. Bank 0 means it's a group of 8 registers. Bank 1 is, it is a group of 8 registers. Bank 2 is a group of 8 registers. Bank 3 is a group of 8 registers. So let us see in detail about this particular bank 0, bank 1, bank 2, and bank 3. So bank 0, it's a group of 8 registers. As I told you, the first register is given the name as R0. The address of that is 0. You can refer to that the first byte with its name like R0 or else with its address like 00. You can refer to the second one, that is R1, with its name like R1 and address is 01. 01 means R1. 2 means R2. Third, a fourth byte is R3. You can refer to that with its name like R3, and then next one is R4, next one is R5, next one is R6, and next one is R7. So these 8 registers are the registers available in bank 0. Similarly, the same type of 8 registers, same 8 registers, the next 8 registers uh, are next 8 bytes are bank 1 bytes. Bank 1 bytes. The next 8 bytes are bank 2 bytes. The next 8 bytes are bank 3 bytes. You can refer to the first byte of bank 1 as R0. The next one as R1. The next one as R2. The next one as R3. Next one is R4, R5, R6, and R7. You can refer to this the first byte with its name like R0 or else with its address 8. See, you can see here, you can see here bank 0 R0 and bank 0 R0 and bank 1 R0. So names are same, but the addresses are different. Addresses are different. Okay. And similarly, bank 2 and bank 3 names are same, but the addresses are different, right? So this is about the register banks. So first one is register bank 0. The second one is register bank 1. Third one is register bank 2, bank 3. Bank means it is a group of 8 bytes. Bank is a group of 8 bytes. The next division is uh, uh, bit addressable bit addressable RAM locations, right? So these 16 bytes are called as bit addressable bytes. Bit addressable bytes. So this is the group of 8 bits. This is the group of 8 bits. Each bit will have one unique address. So that is 00 is the address of this bit. This one is 01. The next bit is 02. Next bit is 03. Next bit is 04, 5, 6, and 7. So you can refer to this byte with its address called 20. This 20 is the byte address. 00 is the bit address. 00 is the bit address. 20 is the byte address. If you want to refer to this entire byte, you have to use this 20. Now you consider this particular 26. 26 is the address of this particular byte. You want to access all these 8 bits at a time, then you have to use this particular address called as the byte address, right? But here 30 is the bit address of this byte, and 31 is the bit address of the next byte, next bit. 32 is the next bit address, 34, 35, 36, 37, like that. So each and every byte is divided into bits. Byte means it's a group of 8 bits. So this 16 bytes are bit addressable. You can store one 8-bit number directly into this, okay, into this particular register, or if you want to store only one particular bit. So like in this location you want to store either 1 or 0, that is possible. In this location you want to store 1 or 0, that also is possible. So right, so if a work is getting completed within a single bit, why to waste a byte? So that is the concept behind this. When you can able to one person can able to do 100 works or 8 works at a time, then why to depute 8 people for a single work? No need. No, one person can able to do 8 works. So no need for 8 people for a single work, right? So when you can able to complete one work, a given task by using a single bit, why to waste 8 bits? So that is the main concept in this particular bit addressable area. So these are the byte addresses and these are the bit addresses. Now coming to the next one, next portion is the general purpose RAM area, where just like any other register, you can store one number temporarily in any of these registers. Okay. Now coming to the PSW, program status word. Program status word is like uh, this is like a flag register, also referred to as flag register. It's an 8-bit register. Among 8 bits, we use only 6 bits. So the first one is carry flag, the next one is auxiliary carry flag, the next one is a parity flag, the next one is overflow flag, the next one is RS0 and RS1. Register select 0, register select 1. Okay, so we use this register select 0 and register select 1 in order to switch from bank 0 to bank 1. You want to use R0 of bank 1, R0 of bank 0, R6 of bank 2, R4 of bank 3, like that. You want to switch from bank 0 to bank 1, bank 1 to bank 2, or bank 2 to bank 3, or bank 3 to bank 1. So then all that is possible with 2 bits of PSW called as register select 0 and register select 1. So this is what is the program status word register. Okay, carry flag, auxiliary carry flag. This is the position of carry flag, auxiliary carry flag, RS1 and RS0, overflow and parity flag. The number of like if you perform any arithmetic and logical operation, so this particular PSW register will be affected. We will see the details of how to switch from one register bank to another register bank using RS0 and RS1. What is this carry flag? When it will be set? When this auxiliary carry flag will be set? What is this F0 and what is these two lines? or what is overflow flag in the next video. So at present, PSW register is an 8-bit register. Among these 8 bits, we use 6 bits. So carry bit, auxiliary carry bit, parity bit, overflow flag bit, and register select 0 and register select 1, which are 6 bits among 8. Two are user defined, used, unused bits are user defined bits. They are okay. Now coming to the ports. Okay, coming to the ports. Port is nothing but register. In microcontroller 8051, 8051, it comes with 4 ports. So we will discuss about ports and the remaining things in the next video. So thank you very much.